Hello everyone. In this video, we are going to talk about the pulverized fuel firing in continuation with the last video. In pulverized fuel firing system, the coal is reduced to a very fine powder with the help of grinding mill, and then it is projected into the combustion chamber with the help of hot air current. A pulverized coal-fired boiler is an industrial or utility boiler that generates thermal energy by burning the pulverized coal, which is also known as powdered coal or coal dust, since it is as fine as the face powder in cosmetic makeup, that is blown into the firebox. Now, the basic idea of a firing system here using the pulverized fuel is to use the whole volume of the furnace for the combustion of the solid fuels. See, coal is ground to the size of a very fine grain, mixed with air and burned in the flue gas flow. Biomass and other material can also be added to the mixture. Coal contains mineral matter which is converted to ash during combustion. The ash is removed as bottom ash and fly ash. The bottom ash is removed at the furnace bottom. This type of boiler dominates the electric power industry, providing steam to drive large turbines. Pulverized coal provides the thermal energy which produces about 50% of the world's electric supply. Pulverized coal power plants are broken down into three categories as subcritical pulverized coal, that is sub-CPC plant, supercritical pulverized coal, that is SCPC plants, and ultra supercritical pulverized coal, that is USCPC plants. The primary difference between the three types of pulverized coal boilers are the operating temperatures and pressures. Subcritical plants operate below the critical point of water, that is 647.096 Kelvin and 22.064 megapascal. Supercritical and ultra supercritical plants operate above the critical point. As the pressures and temperatures increase, so does the operating efficiency. Now, what are the requirements of pulverized fuel firing? There are two types of the requirement which are must for a pulverized coal to burn successfully in the furnace. The first one is presence of large quantities for fine particles of coal, usually that would pass enough through a 200 mesh to ensure spontaneous ignition because of their large surface to volume ratio. And the second requirement is presence of minimum quantity of coarser particles to ensure high combustion efficiency. Now let's see what are the elements of pulverized coal system. So this is the diagram which represents the different elements of a pulverized coal system. Here you can see that there is a bunker from where the coal is supplied. Here there is a feeder. Then there is a primary air to supply to the coal. This is the burner. This is the secondary air duct which supplies the secondary air to this particular burner. So here the amount of air required, which is also known as secondary air, to complete the combustion is supplied separately to the combustion chamber. The resulting turbulence in the combustion chamber helps for uniform mixing of the fuel and air, and the combustion is thorough. The amount of air which is used to carry the coal and to dry it before entering into the combustion chamber is known as primary air, and amount of air which is supplied separately for completing the combustion is known as secondary air. The efficiency of the pulverized fuel firing system mostly depends upon the size of the powder. The fineness of the coal should be such that such as 70% of it would pass through a 200 mesh sieve and 90% should pass through a 50 mesh sieve. Now let us look at the another picture where you can see the actual pulverized coal power plant. So this is a coal hopper. This is a screw conveyor through which the coal is given to the coal pulverizer. These are the draft fans. This is a coal burner, and this coal pulverizer will be given to this coal burner. Now let's talk about what are the process of PCPP, that is advantages of pulverized coal power plant. See, in PCPP, any grade of coal can be used sufficiently because it is powdered before use. Then the higher boiler efficiency due to complete combustion, flexible method, and it can respond well for the sudden change in the demand. Fan power required is low, then it is free from clinker problem. Volume of the furnace required is less. There is no major problem in the ash handling in case of PCPP. The system works successfully with or in combination with gas and oil also. No moving parts in the furnace are subjected to high temperatures. Much smaller quantity of air is required as compared to the stoker firing. The external heating surfaces are free from corrosion. It is possible to use highly preheated secondary air, that is about 350 degrees centigrade, which helps in the rapid flame propagation in this particular case. Then the furnace volume required is also considerably less. Now apart from this, it has also got certain limitations such as additional investment of coal preparation or unit or plant is required. Then extra power is needed for pulverizing the coal. Maintenance cost is more, which depends on quality of the coal. Due to very high temperature, maintenance of furnace wall is difficult. Then more space is required in this case, and special equipment is required to start the system. So these are few disadvantages of pulverized coal systems. So let's discuss it in detail. Pulverized coal preparation using pulverizer or mill. So coal is pulverized. Pulverized means powdered. So coal is powdered to increase its surface area and therefore ultimately its exposure, thus permitting the rapid combustion. The pulverized coal is obtained by grinding the raw coal in pulverizing mills. Okay, there are various types of pulverizing mills such as ball mills, then ball and race mills, hammer mills, bowl mill also. And the essential functions of pulverizing mills are given as drying of the coal, grinding, then separation of particles of a desired size. Coal pulverizing mill reduce coal to powder by any or all actions such as impact, abrasion and crushing. So this particular diagram gives you the flow of coal in a pulverized coal firing system. So this is a raw coal entering into the primary crusher first, then it goes to the magnetic separator, and after the magnetic separator it is separated, then it enters into the dryer, and then it enters into the coal bunkers. In coal dryers, the humidity content of the coal is reduced, and this dry coal is then given to the coal bunkers. From this coal bunkers, this coal enters either in the unit system or central system. Unit system and central systems are nothing but the two systems which are used in the pulverized fuel plants. Okay. So here in unit system, the coal first enters in the scale where it is measured, and then it enters into the pulverizer. From pulverizer, the coal is given to the boilers to the burners in the furnace. Then in central system, again this coal enters into the scale where it is measured, and then it enters into the pulverizer. From the pulverizer, the coal enters into the central bin and then into the feeder. From the feeder, this coal is given to the burners which are kept in the furnace. So this is a general flow of a pulverized coal firing system. Now basically pulverized fuel plants may be divided into two systems based on the methods used for firing the coal. And these two types, as I discussed in the last slide, that these are classified as unit system and central system. So unit system, or it is also called as direct system, and second type is bin system, which is also called as central system. So let us see this unit system and central system in details. Okay, unit system or direct system. So this is the diagram. This is a figure which shows the idea of the unit system. The coal from the bunker drops here. The coal from the bunker drops onto this feeder. The coal is dried in the feeder by passage of the hot gases or the hot air which is coming from the bottom. The coal then moves to a mill for pulverizing. So this is a pulverizing mill. A fan supplies primary air to this pulverizing mill over here. Pulverized coal and primary air, they are mixed over here. They are mixed and they are sent to a burner where the secondary air is also added. Okay. So from here, this burner is a part of the furnace only. So here this coal is burnt. Now in the next slide you are going to see the schematic of this unit system. So here please refer this schematic of this unit system. So most pulverized coal plants are now being installed with unit pulverizer. The unit system is so called from the fact that each burner or burner group and a pulverizer constitutes a unit. Crushed coal is fed to the pulverizing mill. Here this raw coal will be fed to the pulverizing mill at a variable rate, which is governed by the combustion requirement of the boiler and furnace. So primary air is admitted to the mill and becomes the transport air which carries the coal through the short delivery pipe to the burner. So this air may be preheated if mill drying is desirable. Okay. So this air is preheated by using a secondary. This air is preheated by using a secondary air. Then let's talk about the advantages of unit system. Here the layout is simple and it permits easy operation. Then it requires less space is required. It is cheaper than the other type, which is called a central system. Then it allows direct control of combustion from the pulverizer. Simple coal transportation system can be adopted over here. Maintenance charges are less as compared to the other system. There is no complex transportation system. In a replacement of stokers, the old conveyor and bunkers equipments may also be used in this case. Coal which would require drying in order to function satisfactorily in the central system may usually be employed without drying in this particular unit system. Okay. So there is better control over the fuel feed rate. This unit system is also having certain disadvantages, like it is less flexible when it is compared to central system. With the load factor in the common practice, the total capacity of all the mills must be higher than for the control system. Firing is obstructed with pulverized equipment unless it is relegated to the basement. Okay. Here the mills operate at variable load, a condition not especially conducive to best results. Any fault in the coal preparation unit may stop the entire steam generating system. Then excessive wear and tear of the fan blades as it handles air and cold particles both. Okay. Flexibility is less in unit system than in case of the central system. Let us talk about the central system now. Central system is also called as bin system or central system. So here the coal from the bunker is fed by gravity to a dryer where hot air is admitted to dry the coal. So dry coal is then transferred to the pulverizing mill. Pulverized coal then moves to a cyclone separator. Here you can see that there is a cyclone separator given. So this pulverized coal moves to the cyclone separator where transporting air is separated from coal. Primary air is mixed with the coal at the feeder and supplied to the burner. So here you can see that this coal is being conveyed to the feeder, and here the primary air is mixed with the coal at the feeder and then it is supplied to the burner. The secondary air is also supplied separately to complete the combustion. So this is the bin system or central system. In the next slide we are going to see the schematic of the same, that is central system. So this central system, again I am going to repeat here. This system is illustrated in the schematic diagram. Central pulverizing system employs a limited number of large capacity pulverizers at a central point to prepare coal for all the burners, dryers if required, and the dryers, if required, are conveniently installed at this point. From the pulverizers, the coal is transported to a central storage bin where it is deposited, and it's transporting air vented from the bin through a cyclone. Okay, so here you can see the cyclone. This bin may contain from 12 to 24 hours supply of pulverized coal. From the bin, the coal is metered to the burners by motor driven feeders of varied design. Primary air added at the feeders floats the coal to the burners. Now this central system also has got certain advantages. Sorry. Let's talk about the advantages of central system. So central system offers good control of coal fineness. More flexible, it is more flexible because the quantity of fuel and air can be controlled separately. It is more reliable, it has got no problem of excessive wear of fan blades. Then here in this case, less labor is required. There is low power consumption per ton of the coal handled. The disadvantages of the central system are high initial cost, then requirement of large space area, there is a possibility of fire and explosion hazards. The dryers are necessary in this case, that is in central system. Then operation and maintenance costs are high when compared to unit systems of the same capacity. And more number of auxiliaries are needed in central system. The next topic is pulverizer. So pulverizer, the coal is pulverized in order to increase its surface exposure, thus promoting rapid combustion without using large quantities of excess air. A pulverizer is the most important part of the pulverized coal system. Pulverizers are also sometimes called as mills, okay, coal mills or pulverizing mills. And these are classified as attrition mills and impact mills. So attrition mills and impact mills, attrition mills are of two types. First one is ball and race mills, and second one is ball mill. Impact mills are also classified as ball mills and hammer mills. Okay. Pulverizers are driven by electric motors with the feeders either actuated by the main drive or by a small DC motor depending upon the coal control. So let's talk about the ball and the race mill for pulverizing coal. So this is the diagram showing the ball and the race mill. Here you can see that we will just discuss about the construction details first. So this is the fine discharge. These are the rotating classifiers. This is the raw coal feeder. These are the grinding elements which are kept over here. This is the upper race, this is the lower race, these are the balls, and this is the supply of the hot primary air. Okay, so this is a low speed unit in which grinding pressure is maintained by adjustable springs. The coal passes between two rotating elements again and again until it has been pulverized to the desired degree of fineness. Okay, so this is a figure which shows a ball and a race mill. Mill feeder and fan require up to 14 kilowatt hour per ton of the coal pulverized. So this is a low speed unit, as I said, in which grinding pressure is maintained by adjustable springs. These are the two adjustable springs, and the coal passes between the two rotating elements again and again, and until it has it has converted into a powdered form, or it has been pulverized to desired degree of fineness. Then let's talk about the ball mill. So this is a picture of a ball mill. You can see that ball mill operates something like a foundry tumbling barrel. Okay, large rotating drum which is having a speed of about 100 to 200 rpm. It contains a quantity of iron balls mixed with the coal. So as the drum turns, balls are carried upward to be dropped on the coal, while others remaining in the agitated mixture grind the coal at random between them. The coal is fed into one end and reduced in size by this action until it can be swept out of the mill by a current of air. So this is the figure which shows the principle of the ball mill. Now in the next video we will talk about the burners.